transverse wave. A transverse wave is a wave in which the particles of the medium move perpendicular to the direction of motion of the wave. So that is transverse wave. Pretty much straightforward. The first question. Let's take a look at the second question. Name 2 points that are in phase. Again, by definition, if 2 points are in phase, they have a whole number of wavelength in between them. If there's one wavelength between the 2 points in phase, 2 in phase, 3 in phase, 100 in phase, as long as it's a whole number of wavelength in between the 2 points. So let's go ahead and take a look at our sketch. Between A and B, do we have a whole number of wavelength? No, we don't. Between A and C, do we have a whole number of wavelength? Let's go ahead and find out. This is one wave up to this point, and this is the second wave. So between A and C, we have 2 wavelength, 2 complete waves. So those 2 points are in phase. So the answer to 2.1, we have A and C. There's a whole number of complete waves in between the 2 points. Right, let's go to the question that follows. Name the point B. What do we call this point? That is a trough. If it was D, it would be a crest. So there we go. 2.2, that is a trough. And the 2.3, we're supposed to name the point D. Our point D is the crest. Let's move to the questions that follow. Question 3. Determine the amplitude of the wave in meters. Right, let's go ahead and take a look. Just like the question we solved previously, we are given the distance between the trough and the crest. And we know that if we are given the distance from the trough to the crest, you divide it by 2 in order to get the amplitude. So we're going to have the amplitude being equals to 20 divided by 2. This is equals to 10 centimeters. But let's pay attention to details. The question says, let's determine the amplitude of the wave in meters. So we're supposed to convert these 10 centimeters to meters. How do you convert 10 centimeters to meters? You divide by 100, because in 1 meter, there's 100 centimeters. So we're going to have 10 divided by 100, which is equals to 0.1 meters. So there we go. We have the amplitude of the wave in meters. 3.2, we need the wavelength. Take a look at this. We're given the distance from A to C. It is said to be 4 meters. We know that from A to C, we have 2 wavelengths. So from that point to this point here, we have 1 wavelength. Why do we say so? Take a look at this. This is half a circle. This is another half. So 2 halves gives you a whole, and a wave is a complete cycle. So there we go. We have 1 wavelength. And then if we keep going from this point up to C, we have another wavelength. We have a complete cycle. So that 4 centimeters is representing 2 wavelength. So what can we do in a situation like this? We can say that 2 wavelength is equals to 4 meters. Right, we're given the distance of 2 wavelengths, and it is said to be 4 meters. So obviously, we just need to divide both sides by 2. If we do that, the wavelength is equals to 2 meters. And there we go. We have the answer to 3.2. Right, so let's be aware of these type of situations in the exam. Most of the time, you're not going to be given the amplitude or the wavelength. You have to do some calculations to determine it. But anyway, stories. Question 4. 4.1, calculate the period of the wave. We are given the frequency. Obviously, if we are given the frequency, it becomes very easy to compute the period. So we're going to have the period being equals to 1 divided by frequency. This is going to be 1 divided by not 0.5, but 1.5. Our frequency is 1.5. And this will give us 0.67 seconds. So there we go. We have our period. What about the speed? Now we need the speed of the wave. We have the frequency, 1.5 hertz. We have the wavelength, 2 meters. We are looking for the speed. This is pretty much straightforward. The speed is the frequency multiplied by the wavelength. The frequency is 1.5 and the wavelength is 2 meters. This should give us 3 meters per second.